Okay, so we've come this far with the Bro rcSurfer, as I said in part 6, that if this was a regular surfboard, it'd be coming to the end of the process now, perhaps either just leaving it fine sanded or polished, popping the skegs, wax it up and off that goes surfing. But this is an rcSurfer, so really the work's only starting, and what we're going to start with is the housing part where all the RC gumph is stowed. And the important factor for you to realize when you're setting out your housing on your board is to make sure that all your components fit inside. You don't want to go build a housing only to find that you are struggling to fit things in. So for me, this is a tried and tested housing size, but just to demonstrate a way in which you can check out your housing, make sure that you have all your components, your motor obviously, your ESC, your servo, your battery, make sure that it's all going to fit in. It doesn't matter if it's snug, as long as it fits in. Obviously the thickness of the battery needs to be accommodated with the board. In my case here, what I do is I run a 30mm board and you try and keep it as thin as possible because of buoyancy reasons. You don't want too much buoyancy in your board, otherwise you just got to add excess weight for the self-riding process. But what I do, and I'll show you when we do the hatch cover, I actually facilitate a bit of extra volume for the battery, for a bigger battery to be accommodated. So this board can run a 2 to a 4 cell setup, and for the 4 cell it reaches into the extra accommodation in the hatch cover. So let's start out by setting out our housing profile and start following it out. Right, so once you've established your profile for your housing, you either have a template of it or you can, I suppose, mark it out directly onto your board. But this is the time when accuracy is of utmost importance. You don't want to be getting your housing off center or in the wrong position. Try and carry your weight of your board so that sort of the center of the housing's weight distribution would be around about 40% of the CG of the length of the board, just to make sure that your board itself, when it's in the water, has got a slightly set to the tail weight gain. If it's too forward, you don't want the nose to dive in, but if it's too far back, you don't want the nose to rise up. So you just want the fulcrum, let's say, of your balance of your board to be at about 40% from the tail would be ideal in most cases. So fortunately for me, I've done this a few times, got it tried and tested. So I'm just going to mark out my positioning here. I will in the future be producing an ebook. When? I'm not exactly sure, but that ebook will give you some idea of working calculations on how to position all those things. So let's just make sure we've got our center line going here correctly. That's spot on. Good. Okay, so we've got our inside housing area marked out. We're showing where the flange is going to be with the outside perimeter of where we'll have our deflection rim. Let's get this all right. So to get started, a few small basic tools, small grinder with a cutting disc. If you're fortunate to have two, you can just pop a sanding radius disc on the other, or just switch it out if you only have one, no big deal. I like using the Toolcraft range, inexpensive tools, basically repair by replacement, not costly at all. And then we have a small sanding block, with a small radius block, bit of sandpaper, 150 grit, the old good old prisoner dig out spoon, slightly sharpened, which we're going to gouge the foam out with. And then we've got a small steel ruler in this case, and I'll show you that you can use a steel ruler for more than just measuring things with. So let's get this housing started. Okay, so the trick is not to cut on the line. Your rough cut, just start a few millimeters, maybe 2 or 3 millimeters off your line. Make sure that you choose the right line, inside line. Get the revs up. Okay, so there we have our rough cut area. You can see it's just in about 2 or 3 millimeters from the profile line. Just gotta lift it out quickly. Get under there. Pull the lamination back. We have our opening of our housing. We come in with our trusty gouge out spoon. We can just gouge out the foam, work from the outside inward. Don't want to break it away. Gently. Okay, and this is where I come in now with my little steel rule. Got a couple of them and they're just quite hardy. I suppose we could call it a blade in this instance. You can see I've put a slight radius on the corner of the rule, but what I like about it is that it's got a 90-degree flat. So I'm going to scrape the walls now, which will help me keep a perpendicular side wall as I'm cleaning out. This is just a little rough, you can see. Just put it at an angle, walk on the side. Okay, so there we have the housing roughed out. I'm going to take the circular cutter disc on the Dremel and just clean it out to the actual profile line, and then we're going to finalize the actual profile inside. Always tilt your cutter at about a 45-degree angle because you don't want to undercut the foam, otherwise you're going to have a negative when you shape, when you want to laminate the actual wall. Just to mention, if this board had a stringer, it would really just be worthless because your stringer would be negated in this area of the housing. So this is effectively the weakest point of this board, and that's why I think it's important for you to realize that you need to try and maintain as much rail width as you can, as we mentioned earlier. Good strong wraps on the rails, and then by design you can see, you can just see, if you can see by design here, you can see my pod actually extends beyond the length of the actual housing hollow. So effectively it's like an I-beam that's spanned across this length. So we've got the strength in the rail, the pod. We're going to have the strength in the sides being glassed, and then we're also going to have the strength in the hedge cover being located. Right, so we got that roughed out. Now we're going to get stuck in with our sanding. Use a nice radius dowel, big dowel. A bit of sandpaper around it, right under the bottom. Getting here, we can work these radiuses nicely. Get them to be nice and round. So while I'm sanding the fiberglass profile, at the same time I'm forming the foam underneath that to be a nice perpendicular wall, stacking with a bit of block wall here. Okay, when I sand this profile now, what I'm actually doing is putting a slight 45-degree chamfer on this edge over here, so when I glass up, the resin and the glass fiber is going to have a slight key of 45 degrees on the thickness of just the glass, not the foam. Okay, so there we have our hollowed out housing. See the nice clean perpendicular walls. You can see the little chamfer on the edge that when the glass comes up, the resin on the glass is actually going to key in at that ever so slight 45-degree angle, giving that nice location and strength of bond. And so the next thing I'm going to do now, because this is a vertical wall, and we just put our glass fiber in and started glassing it, you really struggle to get saturation. So I'm first going to give this entire wall coat of pigment infused resin, just with a laminating resin, and let that just cure for a while before I actually put the cloth in and laminate the sides. Okay, so we're going to come in now. I'm going to apply a bit of resin to this open foam, just to help with the saturation. Just want to make sure that this foam that we're going to be laminating onto is well saturated with resin, otherwise we're not going to have the best of bonds. And being a vertical surface, it's not as easy to saturate when you're glassing as it would be. You can see what I'm doing here. It would be. There we have it. Housing hollowed out. Got the walls nice and perpendicular. We got them well saturated with laminated resin just prior to laminating it with a layer of cloth. And while that's just kicking off, I'm going to get the red pepper on the operating table and hold out its housing. We have both housings dug out. We have the sidewall saturated. We're just going to leave that to cure for about half an hour, and we'll laminate the inside walls with glass and leave that to cure. Okay, so we got that sorted. Now we're going to glass the inside of the housing. We're going to glass the base and the walls. And I suppose most will just think that the reason we're glassing the sides is to seal it. But more importantly, what we want to do is actually create a key bond between the pan or the floor of the housing and the sidewall. Remembering that we have a battery that's going to be located in here, we've got a motor with a water jacket, we've got a server, we've got an ESC, and I suppose collectively, if you just do the maths roughly, that could weigh up to, I suppose, anything from 600 grams to a kilogram, depending on what you have there. And every time you're landing, that's thumping on this base over here and actually pulling it away from the foam. So if you had no glass key between the base here and the wall, this would start breaking away around the peripheral, and eventually your pan would be loose from the foam of the board. So what we want to achieve today is to, by glassing this, is more importantly than sealing the edge here, is to be able to create a structure as strong as possible between the base and the sidewall to stop any part of the base coming apart from the foam that's already. So if we look at our cloth that we're going to be using to glass the wall, we can see that there's strands that go perpendicular to one another called the warp and the weft. Now if we had to just glass the wall of the housing with strands going parallel with the housing and then strands going vertically, we would actually effectively just have half of the strength of this cloth keying between the sidewall and the base. And what we want to try and do is establish the maximum amount of strength. So what we're going to do is we're going to turn the cloth at 45 degrees. You do get a cloth called plus minus 45, but you can simply take a piece of cloth, turn it at 45 degrees, and effectively what you're going to have now is that you're going to have your piece strands of cloth. Both strands, the ones that would have been horizontal are now going to be turned at 45, and the ones that would have been vertical will be turned at 45, and you're going to have these strands, double strands, going all the way around the wall of the housing onto the pan of the housing, creating a double strength bond between the corner where the housing base and the housing wall meet. So here we go. You can see I'm placing the cloth at a 45 degree angle here. You can see the strands running at 45. We're going to tuck it into the housing, tuck it in, get it in nicely. Try not to separate your cloth too much, just throw it in and then work it out to the outside. Okay, now we want to do this in one piece. So what we're going to have to do is cut a little joint, cut a joint down the center line here, where we can overlap the cloth in the middle so we can maintain one piece of cloth. Connect the back on the center line there. Fold them over. Fold in. Get it tucked nicely onto the floor, pan, and get up to the side. Yeah, just give it a little trim around here. Just get rid of some of this excess cloth. This cloth is just hanging around here. Okay, we make sure that our cloth is tucked in to the corner because that's our area we're trying to reinforce more so than anything. Get it tucked in nicely. Get our overlaps lapped over. Tucked in, tucked in, tucked in. Let's overlap. And do a bit more lapping. Cut this joint a little bit further. Close up, yeah. You can observe here, we have the cloth running at 45, we have the cloth going up that way, and we have the cloth running at 45 going up that way. If we just had it at 90 degrees, the cloth running this way would serve very little purpose in this corner here where we want to keep the pan of the housing to the side. So here we got double strength now, we've got both strands tying that together. Okay, I like to glass the housing before I hollow out the pot, just to make sure that I get this stage done properly, and it just seems to work out a lot easier. So we're going to mix up a laminating resin for this. We want a laminating resin because once this is all done, once we have the pot hollowed out, we're then going to give this entire housing area a complete coat with what we call a top coat, which is like a gel coat. It's also going to be colored, and it's going to have the wax impregnation in it. So then we're going to seal the housing completely with that, as well as the pod area when that's gouged out. So for now we want a laminating resin so that we can key onto that. Right, so I'm going to start wetting out our glass in the corners. Get the base of it all nice and flat. Corner is well saturated. Nicely wetted out. We've already saturated the walls. It's going to go a lot easier glassing it. This layer also acts as part of the housing floor reinforcement. When we spoke about the number of layers of cloth that we have, this becomes our 6th layer, counting layers of cloth, and remembering the amount of weight that this housing is actually carrying. You can imagine sometimes the inertia when this board lands on its belly from a 10-meter drop. You need to be sure you're doing this really well, otherwise you're going to have your pan of your housing break away from the bottom of your board, which you don't want, but at least I don't. Right, so there we have the bottom wet out. I'm now going to work my way around the wall and wet that out nicely. What I'm also doing while I'm wetting this out is making sure that I get saturation on that 45-degree bevel, so that we have a key bond between the deck and the wall side. Just cutting these little slots in this overlap just to relax it on the fold here, so it doesn't tend to want to fold itself in. You can see it relaxes it outwards, especially around the radius. It doesn't pull away from the edge while it's flashing. I like to keep this overlap here, which will trim off only once I've applied the top coat. Just stops all the mess going onto the board. So we got that all glassed in. You can see how nicely it's saturated in the corners there. We've got the plus minus 45 cloth running diagonally either which way you look at it, so we've got double strength around there. Got it well saturated against the wall and got it nicely keyed on the top edge of the deck. We'll just leave that to cure for the rest of today, and Tomorrow we'll hollow out the pod, and we'll give the inside a nice coat of the rough sand. We'll give this inside a nice coat of a top coat, give it a nice smooth finish. Well, this is the end of phase 1 of creating the housing. What we'll do tomorrow is hollow out part of the pod area, part of it stays, part of it becomes a battery platform. And once we've hollowed that out, we need to give the entire housing pod area a coat of top coat, sand the edges, clean that up, start working on the hatch cover and the deflection ring.